Hello and welcome to Sarat Chandra IAS Academy, where your dreams are our mission. This is Yatharth here, and today we are going to talk about the National Quantum Mission. So let's see what is this. I have picked this article from here. So more innovation and a skilled workforce, the promise in India's National Quantum Mission. So what we are going to talk about is National Quantum and Mission. So what's important here is this quantum. So we'll understand what is this, how it has developed as a technology, what are its potential use, and what is the future. Along with which we'll see the challenges involved, basically advantages and disadvantages. All right. So what's being said in the heading is that innovation plus a skilled workforce. When we talk about workforce, we automatically talk about two things. One is demography, and one is the employment of this demography. So in the recent light of the threat that AI has produced for the demographic employment, this can also serve as a solution. The leap in quantum technology, its use, and the workforce and skill that it will offer. All right. So let's see what the subheading says. Strategic recruitment of new talent, synergistic multi-institutional collaboration, and political will to ease bureaucratic norms and prevent delays. So this is also one other topic which we are not going to cover in this video, that the political will. So for our country's advancement, this has been the most critical factor, in fact, even more than the bureaucracy and policy delays. And this has served as a solution to this, in fact. So you can read this as a case study. All right, so these are needed to ensure that the mission's deadlines are met. So let's talk about the context here, first of all, that what we are talking about. Okay, one more thing, let us understand the basic term, which is quanta. So it has been observed again and again that the energy is sometimes transmitted as a wave, but the integral particles of the energy carriers are known as quanta. So quanta are basically a bundle of energy. The smallest bundle possible. Smaller than this is not possible. All right. This is at least how we understand things as of now. So India is getting serious about building her own technology base, and National Quantum Mission could be a game changer in multiple sectors. So please note down the sectors. They are defense, energy production, environment to healthcare and civil applications. So any technology is first devised and then thrives on material innovation. And quantum technology is no exception. So it will cater to the semiconductor mission. This is also a very, very important topic that you should read. 4x5 important. To neutrino observatory and gravitational wave detection. This we have already covered in science and tech. The infrastructure will play a key role in building self-reliance in energy and electronics industries. All right, so let's see about National Quantum Mission. So recently, the Union Cabinet, chaired by Prime Minister Narendra Modi, has approved the National Quantum Mission, that is NQM. It shall be implemented by the Department of Science and Technology, that is DST. So please note this down, it's very important, under the Ministry of Science and Technology. The mission has planned for 2023 to 31, that's almost 8 years, to send, nurture, and scale up scientific and industrial research and development, and create a vibrant and innovative ecosystem in quantum technology, that is QT. With the launch of this mission, India will be the 7th country to have a dedicated quantum mission after the US, Austria, Finland, France, Canada, and China. All right. So let's first see what is the quantum technology. So quantum technology is based on the principles of quantum mechanics. We'll understand this in a little detail. Not much detail again, but a little. All right. So that was developed in the early 20th century to describe nature at the scale of atoms and elementary particles. So right now the model that we use to understand things and their behavior is little different from the quantum technology model. We understand that, let's say, in an atom, this is the nucleus. So it has proton and neutrons, and electrons are in some outer orbits, specific orbits. Alright, these orbits have certain energy. So these are energy orbits. Electron can jump from one orbit to other or come down from the outer orbit to the inner orbit. And it will take some energy, some kind of energy for electron to do so. So this is the current model. But the one more way to explain it through the quantum mechanics is actually that these orbits are where the probability of finding the electron is maximum. Electrons can be here also, but the probability of finding electrons in these orbits are the maximum because of a certain energy, because of a certain total energy. This is why the quantum technology or the quantum mechanics does not explain things in binary terms. In the binary terms mean either it is here or not here. The quantum technology says that electron can be anywhere, the behavior can be anything, just that the probability of finding the electron at these 2 points is maximum. It does not say that it cannot be here. While the binary system or the current mechanical system says that it cannot be here. Alright. So this has given us very new technologies, new possibilities. We'll see them. Okay. So the first phase of revolutionary technology has provided the foundations of our understanding of the physical world, including the interaction of light and matter, and led to ubiquitous inventions such as lasers and semiconductor transistors. So you must have heard about the uncertainty principle. Let me just tell it to you. It's Heisenberg's uncertainty principle. It simply says, you must have read it in 11th class, it simply says that either the speed or the position, either the speed or position can be accurately detected for an electron. If either we want to, let's say, more accurately detect the speed, the position will differ. Or if we want to accurately see the position, then we will not be able to see the speed of the electron. There is certain uncertainty that will be there. It also shows, the Heisenberg's uncertainty principle in a matter shows that electrons, atoms, and molecules often behave like particles. This is our general understanding. But the quantum mechanics says that these particles actually also behave like waves. The wave-particle duality of the matter is one of the fundamental, let's say, premise of the quantum mechanics. Let me just explain it more to you. So let's say we see a tennis ball, a big tennis ball, or a football, even a football. So it behaves like a particle in the real world in front of us. But that is because the wave nature of this football has reduced so much that it does not display the wave qualities. It only displays the particle qualities. But as we go to the subatomic levels, as we go to the atomic levels, we talk about the electrons, they display not only particle-like behavior, but also wave-like behavior. So this is a fundamental fact of the quantum mechanics. So this is what I shown you, that instead of the bits, the quantum mechanics uses qubits. It understands the qubits. Please also understand, that quantum mechanics is just a model. Quantum mechanics is just a model. It is not a reality. It is a model to understanding how things might be working in real life, how physics might be working. Phenomena are anyway taking place. They have always taken place. Since the dawn of the universe, they have always taken place in the way they take place. Quantum mechanics is a model to understand how. There are some things which the particle physics is not able to understand or explain. In fact, That's why this quantum mechanical model is there. So in order to explain that how some other things might be working. All right. So this is not something, let's say, real or material. It's something that is a model, just a model to understand things. All right. So let's see this diagram. So here we understand the operations through the qubit, not the bit, which we usually use in our computer calculations. 8 bits make a byte, 1 byte, and then 1024 bytes, let's say they make an MB, megabyte, and GB, gigabyte. So these are the storage unit or the calculative units of the general computers. But now we feed them the model of the quantum mechanics. So they start calculating by using qubits. It of course requires different hardware. It requires different hardware that understand this quantum mechanical software. All right. Okay. So this is about the qubit. Let us understand two more things about the quantum mechanics, which will be of use to you in the future. All right. So one of the qualities that quantum mechanical models display is superposition. So what is superposition? That in the, let's say, normal operation, it can either be on or off. But in the quantum mechanical model, it can be both 1 or 0, on or off. So it will, let's say, be classified. It will be determined when you want to see the outcome. You must have heard about the Schrodinger's cat. Just a second. So you must have heard about the Schrodinger's cat. So in the box, we cannot see if the cat is alive or dead. There is a famous saying also that curiosity killed the cat. That curiosity killed the cat. So in the box, there is a cat. It is both alive and dead. But we only get to know as soon as we open the box. All right. So this is the same thing that quantum mechanical models do. That the outcome is determined as we want to see the outcome. Okay, this is qubits. So the qubit is always in a position 0 and 1, and when we want to see the outcome, it determines its position. So this characteristics expands the possibility of parallel calculations. All right, not very necessary to understand. It's something that is, let's say, can be explained, and if you are curious enough, you can read more about it. Okay, another property is this entanglement. It's known as the quantum entanglement. It simply says that when something comes out from the single source, let's say we are talking about the laser beam here, so it may have photons. So when they are divided by a crystal of some structure, here is the crystal, then it can divide photons into two parts, vertically polarized protons and horizontally polarized protons. However, both of them, whether a photon is divided into two parts, the vertical ones and the horizontal ones, they will be known as the entangled particles or entangled photons. This means they have come from the single source and now further divided into two parts, vertical and horizontal. So what does this mean? It means that when two particles are entangled, the particle, let's say A and B, so we cannot determine if A alone is horizontal or vertical. But if we determine that it is vertical, then the B automatically takes the horizontal photon shape or horizontal photon phase. This is also known as a spooky action at a distance. That we cannot determine individually their phases, whether they are horizontal or vertical. But as soon as we determine one, the B automatically certainly takes one phase, either this or this, despite the distance between them. You can place one on Earth, you can place the second on Mars. So this is not even momentary, this phase thing. You can read more about it, quantum entanglement. Okay, the third property is quantum interference. So what is this quantum interference? That a wave here, this is laser light, it's acting like a wave. Can we divide it further via certain filters into individual photons also? Now, this here is the division, let's say. They are divided into, let's say, vertical, or here they are vertical photons. And here they are horizontal filter, let's say. So this can be divided into single photons as well. They won't interfere with each other, but if they are combined, then they will form a wave. So this is also a principle of the quantum interference. Okay, now let's see what is the advantage of quantum technology. Just a second. So why we are popularizing it as a mission. So increased computing power. So basically earlier we were calculating between 0 and 1 only, in these two figures only. Now we'll be able to calculate everything between 0 and 1. So infinite parallel, let's say, calculations can be done depending upon how strong the hardware is. If we make understand the computer that this is how things work according to quantum mechanical model, then it will be able to calculate more in same time. Alright. So quantum computers are very much faster. Why they are faster? Because they are able to see all the possible outcomes, and then they will give the most possible outcome to us. So they also have the capability to solve complex problems that are currently beyond our reach. One is improved security. So because they rely on principle of quantum mechanics, quantum encryption techniques are much more secure. So more combinations, basically more permutations, more combinations. So this will be the complete advantage. Increased computing power, improved security, faster communication. All right. Enhanced AI. So they will also help the AI in order to be better and more efficient. Better sensing and measurement. So this can be very, very helpful for us in medical diagnostics, environmental monitoring, and geological exploration. All right. Now let's see what are the disadvantages. So one thing, it's expensive, of course. The first thing is that making the hardware is expensive, making such a strong hardware. So first of all, this is very expensive, and then integrating it with the software that correctly understand the quantum mechanics, that we also don't completely understand by now. So this is also a difficult task. Other thing is limited application. So currently quantum technology is only useful for specific applications such as cryptography, quantum computing, and quantum communication. So we have only learned this yet. In future, when we develop stronger hardware, stronger software, then we'll be able to make other models for the same quantum physical model, which will explain more things that this model can explain. So it's a loop-like structure, but this is how things happen. When the computer was developed, we could do more calculations. Let's say if we are making this bridge. All right. So if we feed the data to the computer, I'll explain it on the, let's say, another page. Wait. Okay. So let's say we are talking about the particle model. We take this element, it's, let's say, iron. And now we feed the computer that the density of the iron is this. This is the weight bearing capacity. And this is its volume, or whatever its cost, or how it is used. Then the computer can calculate that what kind of a bridge can be built using the iron. If this design is yes, okay, and it can bear the weight of the vehicles passing by, or it cannot. All right. And if the computer says, okay, yes, this model will be successful, then we start building this. And before the computer came, this was not possible. This was relying on the experience. So this is how we are going to work with the quantum mechanical model eventually also. So qubits are easily disrupted by their surrounding, which can cause them to lose their quantum properties and make mistakes in calculation. So qubits, again, when we are talking about the qubits, they can be bundle of energies, and they can be interfered by the magnetic or electric fields also. The hardware calculation can be disturbed. Okay, one thing is limited control. So it's difficult to control and manipulate quantum systems because we do not understand them enough yet. Quantum powered AI could create unintended consequences. So this can also become a threat because they will calculate all the possibilities initially, that if we do this, then humans can do this. All right, and they may even choose the most threatful path. All right, when we talk about the quantum powered AI system, they could potentially arrive at conclusions that the unexpected or difficult to explain, as they operate on principles that are fundamentally different from classical computing. All right. What is features of NQM? So this is our main topic, National Quantum Mission. So it will target developing intermediate scale quantum computers with 50 to 100 physical qubits in 5 years and 50 to 1000 physical qubits in 8 years. Just like bits are the basic units with which computer process information, qubits or quantum bits are the units of process by quantum computers. The mission will help develop magnetometers with high intensity for precision timing. These are atomic clocks, communication, and navigation. It will also support design and synthesis of quantum materials such as superconductors, novel semiconductor structures, and topological materials for fabrication of quantum devices. What is topography? It's the study of the outer layers of things. Alright. This mission will also help development of satellite based secure quantum communication between ground stations over a range of 2000 km within India. So these are some goals which you can write down. Long distance secure quantum communication with other countries. Intercity quantum key distribution over 2000 kilometers. Multi-node quantum network with quantum memories. So to understand all this, it's very, very important that you understand the basic facts of the quantum technology. I have tried to explain as much as I could, but of course you can read more in more time and see how it works. Alright. So 4 thematic hubs would be set up in top academic and national research and development institutions on the domains of quantum technology, which are quantum computation, quantum communication, quantum sensing and meteorology, and quantum materials and devices. This is related to weather. Alright. So this will accelerate, this is the outcome, that will be the outcome of this quantum mission. So this will accelerate quantum technology-led economic growth and make India one of the leading nations in the development of quantum technologies and applications, ranging from healthcare and diagnostics, defense, energy, and data security. Also, it will work towards indigenously building quantum-based computers, which are far more powerful and are able to solve the most complex problems in a highly secure manner. So this will be the future of the technology. I strongly encourage you, whether even if it does not look very relevant to you right now, it will be very, very helpful for you to understand both the physical models or the classical models and the quantum models. You should see what is actually mean by the qubit and how these computers work or solve their problems. This can come as a prelims question with options that may look closely resembling to each other, but a definitive fact will decide the answer. The quantum technology, understanding this can also help you very, very much to solve problems in the quantum way. And this is something that you will understand when you will read about it. Alright, so I hope you understood much in this lecture. Thank you very much and have a very good day. I'll see you in the next meeting, in the next lecture actually. So keep studying and be bright.